This is a Lorenz LO15 teletype machine that was manufactured sometime in the 1950s. In the last video, we carefully removed the keyboard and the printing unit so that we could perform a much needed cleaning and lubrication of this beautiful machine. And after installing a brand new ribbon, we were finally able to take this machine for a test drive. And now that it's working, let's see if we can use the TTY modem, which is that gray box on the right, to send some data to the Teletype machine. Now before I start plugging anything into this modem, I need to first address this keyboard and printer cable set. Clearly, they've seen a lot of action and it's time for their well-deserved retirement. So first things first is to move the modem to a safer place for now. And next, I'll remove this protective cover that's held on by these two slotted screws at the bottom. The bottom terminals are the AC power and ground connections, and then our keyboard and printer terminals are on the top. And since our cable is threaded behind this AC terminal, we'll need to unscrew both sets of terminals. Next, it's on to removing the two connections for the printing unit, and then onto the other two connections for the keyboard. And with those removed, we can see these S and E labels, which makes more sense when you consider that this machine was made in Germany. Back to the cable, it's being a bit difficult to remove since it was threaded between two of the AC connections, so I'll just remove the left one temporarily. And with that out of the way, it's time to say so long, old cables, and hello, new cables. Now, I could just use these as is, but I want to build something that has a more factory finished appearance. So I'll start by using this expandable braided sleeving, and I've never used this stuff before, so it should prove interesting. And I started off strong by using tweezers to keep this sleeve open, and then get the first cable threaded, and for some reason I removed the tweezers, and I'm not sure why I removed the tweezers, so on the second attempt, I managed to get both cables through while the tweezers are still in place, and then remove the tweezers. And the rest was just working this braided sleeving up the cable, which took some patience to keep the cables aligned nicely. And since the sleeving ends will likely unravel, I'm using some outer layers of shrink tubing and a bit of heat to keep the entire thing looking presentable. And finally, I just needed to add some ring terminals and some color wrap to more or less match the original cable. Now, this new cable was a tighter fit than the original thanks to the shrink tubing, so I took it slow when reinstalling the terminals to avoid stressing or cracking anything. And then it was on to reinstalling the two printer and the two keyboard connections. And then the finale was this AC line that keeps our new cable centered, just like it did with the original one. And then it was just a reinstall of the cover plate, which keeps our fingers away from the household current when this machine is plugged back in. And now it's the proverbial moment of truth by testing this new cable. Now, one thing I've noticed is that this indicator light should be lit whenever the unit is on, and it just so happens that this machine came with this spare bulb, and I'm not sure if it's the right size, but there's only one way to find out. And these are just like automotive bulbs, so just a push and a twist to get them out, and then the same gesture to install the new one. And after reinstalling the cover, I made an attempt to wipe some of the grime off, but it's pretty deep, so we'll say it just adds character. And behold, we have light. In my excitement, I ran over to the RTTY site and tried running some of their audio through this modem, but nothing really seemed to register, and at that point I figured I'd better stop and look up some documentation for this modem. I googled the name and manufacturer on the back label, which didn't turn up anything, but I was able to use the patent number to perform a search on the US Patent and Trademark Office's website, and this produced a nicely scanned copy of the original patent for this modem. And it was at this same time that Patreon member Chris Falla connected me with John Lucas, who you may have seen doing some very cool Teletype stuff on the ASCII Electric channel. And John graciously provided some details on what hardware modifications would be needed to change the internal frequencies of this modem if I wanted to use online TTY audio. Before I go ahead and perform surgery on this modem, there's one more thing I want to try first. This page in the patent caught my eye since I had previously built a working pulse and frequency generator using an Arduino. We'll start by grabbing the Arduino knockoff, and we'll also need a speaker and a breadboard, which in this case is just used to house a resistor connected between pin 8 and the speaker, and then the other speaker lead completes the circuit to ground. Starting with the patent diagram, we can see that this modem works with these two frequencies, so in the code, I'll just define those frequencies for the mark and the space pulses. Now that we have the frequencies, we'll go back to the patent where we find the details on the timing of these pulses. The first 6 pulses are at intervals of 22 milliseconds, whereas the final stop pulse is 31 milliseconds. So back to the code to define the timing of these two durations in milliseconds. The next step is to set up the GPIO pin 8 to output, and then I generally put in a small delay before the main loop is run. Next is the use of the Arduino tone function, which in this case will output to pin 8 at the defined frequency of 1800 Hz and a duration of 22 milliseconds. And this becomes our start pulse. And after each tone function call, we just need to add a delay matching the duration of the tone. The next tone will use the mark frequency of 1400 Hz, and then set the duration to 2 times 22 milliseconds, as this represents our first 2 bits. And then we just continue with the next 3 bits, and finally end off our stop pulse with a 31 millisecond duration. And before I run this, I'm just going to add a loop so that it will send the same character 5 times, and also add an endless while loop at the end to stop the output afterwards. So let's hear what this sounds like on the speaker. Well, it sounds alright to me, but let's see if the modem agrees. Now, this speaker almost fell off, so I'm going to try to use this 2-inch speaker, which looks like it will be a great fit. And after soldering on some standard speaker wire, I added the resistor inline under the wrap so that I can do away with the breadboard. The 5-bit Baudot, or ITA2 codes, are not assigned to characters in a sequential format like ASCII, so if I want to print the entire alphabet, I'll need to create an array that contains all of the ITA2 codes in that order. At the end of the array, I'll also add in the codes for a carriage return and line feed, and then update the main code loop to parse the array values and output the frequencies and durations. And we can see a couple of glaring issues with this first attempt at printing the complete alphabet. So I added a small delay after each character just to see if that makes any difference. The final frontier for me now is to be able to print any string of characters. And since we already have an array of the ITA2 codes, it should just be a matter of adding another column of ASCII codes that we can be using as a lookup for each character. But with the Teletype, there's a small wrinkle in that plan because each of the ITA2 codes represents both letters and figures. And we can see this if we take a closer look at these type bars that strike the ribbon to imprint the characters on the paper. And looking more closely at these bars, we can see that each of them contains 2 characters. And when figures is pressed, the platen shifts up, which causes the top character on the type bar to make contact. And when the letters is pressed, the platen shifts down, which then prints all of the lower characters on the type bar. So for each ASCII character in our lookup table, we will also include a flag that indicates if this character uses the letters or figures mode. Now, we also don't want to send the letters or figures code to the Teletype each time any character is printed, so there's some extra smarts added to the code that sends this code only when this mode truly needs to be changed. And for this boss level test, we can define a custom string that contains any of the printable and control characters that will be sent to the Teletype. What a way to end off 2025. I've been wanting to send custom text to this machine since I picked it up, and this is just a step closer to the journey of getting the relay computer talking with this device. So I'm going to end off on this high note and thank you all so much for making 2025 an amazing year. Have a very Merry Christmas, and I'll see you in the new year.